Okay, this video is going to be about the drill press head that I'm modifying. I'm putting a BT30 tool holder on it, adapting one to it. So let me put you up here. Okay, this is that drill press head that I had earlier. And what I wanted to do was I wanted to take a BT30 tool holder and adapt it, because this is going to go on my 3-axis / 5-axis machine. So it's pretty much stock, except I turned the diameter here to give me a true surface. But okay, the issue is that I was going to use the stock quill, but this is big, and I had that aluminum adapter, this one, that I made to hold this piece. I got the little locking lugs right here. I made this aluminum adapter, and by the time I adapt it, it's big. Well, I knew it was big. So what I'm going to have to do is I'm going to have to put it back here. I got a much bigger diameter to work with. This the one on front was a little over 1.5 inches, and this one's 2 1/4, the one in the back. So I got these bearings, just typical roller bearings, and I really can't put it up there. As much as I'd like to, I can't. Because I don't want to have to modify this because the whole idea of using this is so I didn't have to start with a solid piece of block or pieces and then weld them together and make sure it's all aligned and fit and all that. And so this was already there. So what I'm going to do now is I'm going to use these bores. This is the bore that fits on the shaft in the back, the stand, I guess you would call it. And this one bore is way down here. And the other bore is here at the bottom. So what I thought I'd do is I made these adapters to fit in here. I made one for the bottom, and I made one for the top. And this one had to be longer because that bore diameter is further into this piece. So that's going to fit in there like that. And then I bored it out for this bearing. Now when I made this part, I put these three holes in here, so if something happened I could punch the bearing back out. Because, you know, sometimes you start these bearings, they go in crooked and this and that, and sometimes it doesn't work right, so it's just as easy to put three holes in there so I could punch it out in case something happened. But what I ended up doing was I took these two pieces and I got the ring to just barely fit in, and then so there's about a 1/2,000 press fit. So I took these rings and I put them in the oven, put it up to 380 to see if it would expand it enough for me to drop that outer race in there. And I wasn't sure if it was going to work or not, but it did. I was really surprised. It opened it right up, and I was able to drop that race in there. And then when it cooled off, it collapsed on that race, and that's holding it on there pretty tight. So I got one on the bottom, one on the top, and then I made a shaft. So this shaft is made out of a piece of stainless steel tubing. It's hollow on the inside. And the reason I did that is I didn't want to have to make a shaft out of a solid piece, because it would take me forever with the little machines I have. So I thought I would make it in pieces, build it up, weld it, and then turn it. So that's what I did. I took this shaft, I made these rings to fit on here to fit the bearing, fit the ID of the bearing, and I had them welded on there. And then I made this flange on the bottom, and I had that welded on there. I got 3 wells, and I wanted wells on the inside, but the guy he couldn't weld that small, I guess. But anyway, it should work. So I got a ring here, and I got a ring here, and I just trued up the shaft because it was running just a little bit out. You could see, I don't know if you could see that right there where it ran just a little bit out. Well, you know, it's just a piece of tubing, so it's not a precision piece of stock. So I put it in the 3-jaw and I faced it off. I trued up this surface. I trued up the back surface. And then I bored it out. I bored this out. And I bored this out. Well, I turned this to fit in there to act as a pilot. Then I drilled these holes. These are tapped holes here. And these are holes through here to attach this piece to this piece. Originally, these holes inside were to attach it. The ones I made before, I showed you earlier. But it's too small. I needed a bigger surface. So this surface rides against this surface, and then this surface rides inside of that surface to act as a pilot. So then I threaded it because I was going to make a pulley, and I was really surprised because when I threaded it, I really didn't think it was going to work, because this material is stainless steel, and my little lathe See, when I bought, it's not the lathe, it's the tool holder. When I bought the tool holder, they make two different types. They make a piston type, which has a little cylinder that comes out and it pushes against the tool holder from the centerpiece. Then they make the wedge, and they have slides on the wedge that when you lock it, it won't allow it to move. But when I bought this was a long time ago, maybe 10 years ago. You know, I thought, well, the piston one would work because I didn't know any better, and it was cheaper. And that's why it's cheaper, because the tool holder will move if it's under a lot of pressure, and it doesn't really repeat. When you put it on and take it off, it won't repeat. But it was just for, you know, hobby purposes. Anyway, I was able to generate that thread, and I was really surprised, and it worked out. So I'm going to put a pulley here. I was going to make one. I got this belt, and I needed a wider belt, and it was really hard to find a wider one. So what I ended up doing was just ordered one from that SDP SI, and I'll just modify it. I know it's the one I ordered is not much wider than this, but it's mostly just to get it going, keep the project going. So I got to put a little keyway in here. But that's kind of like the new plan now, is I'm going to put this in here with this, and then gonna have the holder adapt into here. So that's what I'm working on now. And I think it'll work. There's no reason why it shouldn't work. So what these slots are for is access holes for the bolt to fit into, to thread into this stainless steel part. There's 8 of those. I mean 6 of them. So I got to put a slot in here. I want to put a tapered slot in here so I could use an Allen handle to tighten those screws. Because what I didn't want to do is I didn't want to drill those holes from the end. See, these original ones I drilled from the inside, and I didn't want to have to drill this whole distance if I didn't have to. Because, I mean, I could have, but I thought, well, you know, that's basically too easy. You know, anybody could do that. Just drill a hole down there and then, you know, just push the screw through there and tighten it up. But then I'd have all these holes on the bottom, and I was trying to keep it kind of clean because I didn't want chips to get in there and pack up. Not that they would have hurt anything, but this was a little different. I tend to do things a little different. So we're not going to use these inner holes anymore. We're going to use these outer holes against this shaft. So that's what I'm thinking. But I'm thinking that'll work. All right. I'll let you know what happens. Yeah, this is a 3/4 diameter here.